questions in the image you provided are related to electrical circuits and their analysis. Here's a detailed explanation and answer for each part. 1. A. Define alternating current and phase. Alternating current, AC. An alternating current is a type of electrical current that reverses direction periodically. Unlike direct current, DC, which flows in one direction, AC periodically changes direction and magnitude. The most common form of AC is sinusoidal. Phase. In AC circuits, phase refers to the position of the waveform relative to a reference point in time. It is expressed in terms of angles, degrees, or radians, and shows how the voltages and currents are aligned in relation to each other. 1. Derive the average value of an alternating current. The average value of a sinusoidal AC current is calculated as I text AV's C dot I max, where I text AV is the average value of the current. I text max is the maximum or peak value of the current. For a sinusoidal AC current, the average value over a complete cycle from 0 to 2 pi is derived by integrating the instantaneous current function over one full cycle. 1. C. What do you mean by resonance of a circuit? Show that the resonance frequency of a series RLC circuit is F0 equals frac 1, 2, LC. Resonance in a circuit occurs when the inductive reactance and capacitive reactance in a series RLC circuit are equal in magnitude but opposite in phase, leading to a condition where the impedance of the circuit is purely resistive. At resonance, the current reaches its maximum value. Resonance frequency. The resonance frequency, F0, of a series RLC circuit is given by F0 equal frac 1, 2 paret LC, where mer L is the inductance in Henry's H, Mave C is the capacitance in farads F. To derive this, 1. The inductive reactance XL is XL equals 2 pi FL. 2. The capacitive reactance XC is XC equals frac 1, 2 pi FC. 3. At resonance, XL equals XC, so 2 pi FL equals frac 1, 2 pi FC. For solving for F, you get F0 equals 2 pi script LC. A coil with an inductance of 50 milliamperes and resistance of 10 ohms is connected in series with a 25 microfarad capacitor across a 200-volt AC supply. Calculate minus I resonance frequency of the circuit, minus T current flowing at resonance, T Q factor. Given data, L equals 50 text MH equals 50 times 10 minus 3 text H, R equals 10 omega, C equals 25, mu text F equals 25 times 10 minus 6 F, V equals 200, text V, AC supply. 1. Resonance frequency, F0 equal frac 1, 2 pi LC. Substituting the values, F0 equal frac 1, 50 times 10 to 3, 25 10 minus 6, approx 318.31, text hertz. 2. Current at resonance. At resonance, the impedance is Z equals R, so the current is I equals frac V, Z equals frac 220 equals text A. 3. Q factor. The Q factor is given by Q equals frac F0 LR. Substituting the values, Q equals frac 318.31, 50 times 10 q minus 3, 10, approx 1.59. 2. A. State and explain KCL and KVL. KCL, Kirchhoff's current law. KCL states that the sum of currents entering a junction in an electrical circuit is equal to the sum of currents leaving the junction. Mathematically, sum I text out. KVL, Kirchhoff's voltage law. KVL states that the sum of the voltages around any closed loop in a circuit is 0. This is because the total energy supplied by sources is equal to the total energy consumed by resistances and other components. Sum V text loop equals 0. 2. B. Find the current I of the following circuit using superposition theorem. Superposition theorem involves solving a circuit with multiple sources by considering each source one at a time while turning off the others, replacing voltage sources with short circuits and current sources with open circuits. For the given circuit, the two sources are a 10-volt voltage source and a current source of 40 AS. To solve, 1. First, consider only the 10-volt voltage source. Replace the 48 current source with an open circuit. Solve the circuit as a simple voltage divider or use Ohm's law to find the current. 2. Next, consider only the 40 at current source. Replace the 10-volt voltage source with a short circuit. Calculate the current due to the current source. Finally, combine the individual currents from each source using superposition, add them algebraically. 2. C. Obtain the Thevenin's equivalent circuit with respect to terminals A and B. To find the Thevenin equivalent, 1. Open circuit voltage, V text OC, the voltage across terminals A and B when the load is removed. 2. Thevenin resistance, R text, the resistance seen by the load when all independent sources are turned off. Voltage sources replaced by short circuits and current sources is replaced by open circuits. The given network needs to be analyzed for and to find the Thevenin equivalent circuit. This covers the main concepts and steps for solving the given problems. If you'd like further assistance or detailed calculations for any part, feel free to ask. Answer 3. A. Explain the classification of material according to energy bands. Materials are classified into 3 categories based on their energy band structure. 1. Conductors. Conductors have overlapping valence and conduction bands, allowing electrons to move freely. Examples: copper, silver, gold. 2. Semiconductors. Semiconductors have a small energy gap, 1 eV, between the valence and conduction bands. At absolute zero, semiconductors behave like insulators, but at room temperature, some electrons can jump to the conduction band. Examples: silicon, germanium. 3. Insulators. Insulators have a large band gap, greater than 5 eVs, preventing electron flow under normal conditions. Examples: glass, rubber, plastic. SAC 3. What is doping? Explain the doping process for extrinsic semiconductors. Doping is the process of adding impurity atoms to a pure semiconductor to modify its electrical properties. Types of extrinsic semiconductors. 1. N-type semiconductor, doped with pentavalent atoms, e.g. phosphorus, arsenic, increases free electrons, making electrons the majority charge carriers. 2. P-type semiconductor, doped with trivalent atoms, e.g. boron, gallium, increases holes, making holes the majority charge carriers. Doping enhances conductivity by increasing charge carriers in semiconductors. 3. C. What is a p-n junction? Describe its conditions under I, no bias, I, forward bias, and 3, reverse bias. A p-n junction is the basic building block of semiconductor devices formed by joining a p-type and an n-type semiconductor. 1. No bias condition. No external voltage is applied. A depletion region is formed due to electron-hole recombination. A built-in potential, barrier potential, exists, preventing charge flow. 2. Forward bias condition. The P side is connected to the positive terminal and the N side to the negative terminal of a power source. The depletion region narrows, allowing current to flow. 3. Reverse bias condition. The P side is connected to the negative terminal and the N side to the positive terminal. The depletion region widens, preventing current flow except for a small leakage current. 4. A. What is a transistor? Describe the working principle of a transistor. A transistor is a semiconductor device used for amplification and switching. Types: bipolar junction transistor, BJT, field effect transistor, FET. Working principle: the transistor consists of 3 regions: emitter, base, and collector. In BJT, small current at the base controls a larger current between the emitter and collector. In FET, voltage at the gate controls the current flow between source and drain. 4. B. Describe the operation of a transistor as an amplifier. A transistor amplifies weak electrical signals by increasing their power. 1. Common emitter amplifier configuration. Input is applied to the base emitter junction. Output is taken from the collector emitter terminals, provides high gain and phase inversion. 2. Working principle. A small input signal at the base is amplified to a larger output signal at the collector. The transistor operates in the active region to function as an amplifier. 4. C. Draw and explain input and output characteristics of a common base configuration of BJT. Input characteristics shows the relationship between base emitter voltage, VBE, and base current, IB, for different collector emitter voltages, VCE. Similar to a forward bias diode curve. Output characteristics shows the relationship between collector emitter voltage, VCE, and collector current, IC, for different base currents, IB. The transistor operates in 3 regions. 1. Cutoff region, no current flows. 2. Active region. The transistor amplifies the signal. 3. Saturation region. maximum current flows. 4D, distinguish between BJT and FET. Feature, BJT, bipolar junction transistor, FET, field effect transistor. Carrier type, uses both electrons and holes, uses either electrons, N-channel, or holes, P-channel. Control mechanism, controlled by current, controlled by voltage. Input impedance, low, high. Power consumption, higher, lower. Switching speed, slower, faster. Thermal stability, less stable, more stable. If you need more elaboration, let me know. Watch 5. A. What is an operational amplifier? What are the salient features of an op-amp? An operational amplifier, op-amp, is a high-gain electronic voltage amplifier with differential inputs and a single-ended output. It is widely used in signal processing, filtering, and mathematical operations like addition, subtraction, differentiation, and integration. Salient features of an op-amp: high gain, has an extremely high open-loop voltage gain, typically 100,000. 2. High input impedance, prevents loading of the source circuit. 3. Low output impedance, ensures efficient power transfer to the load. 4. High common mode rejection ratio, CMRR, minimizes unwanted noise. 5. Wide bandwidth, supports a broad range of frequencies. 6. Low offset voltage, reduces the need for external calibration. Have 5B. Define CMRR and skew rate. 1. Common mode rejection ratio, CMRR. CMRR equals differential gain, common mode gain. A high CMRR means the op-amp can reject common mode noise effectively. 2. Slew rate, the maximum rate of change of the op-amp's output voltage per unit time, measured in VSMIP. A higher slew rate ensures better performance at high frequencies. C. How an operational amplifier can be used as a differentiator. A differentiator circuit produces an output proportional to the rate of change of the input voltage. Circuit components: a capacitor in series with the input, a resistor in the feedback path. Application: used in signal processing, edge detection in images, and frequency modulation. T. Summing amplifier. A summing amplifier combines multiple input signals into a single output. Circuit components: multiple input resistors connected to the inverting terminal, a feedback resistor to control gain. Application: used in audio mixing, digital to analog conversion, and voltage level shifting. 5D. What is feedback? How does negative feedback reduce noise and nonlinear distortion? Feedback is the process of feeding a portion of the output signal back into the input. Types of feedback. 1. Positive feedback, increases gain but may cause instability. 2. Negative feedback, reduces gain but improves stability and performance. How negative feedback reduces noise and distortion. 1. Stability improvement, prevents excessive gain variations. 2. Noise reduction, suppresses unwanted high-frequency signals. 3. Linearity enhancement, reduces harmonic distortion, making the output more accurate. A. Describe the basic operation of JFET with a diagram. A junction field effect transistor, JFET, is a 3-terminal semiconductor device that controls current flow using an electric field. Working principle: the JFET has 3 terminals: source S, drain D, and gate G. When a voltage is applied between the drain and source, current flows through the channel. Applying a reverse voltage at the gate reduces the channel width, controlling the current flow. Modes of operation: 1. Ohmic region. The transistor behaves like a resistor. 2. Active region. The transistor acts as an amplifier. 3. Cutoff region. The transistor is fully off. 6B. What are the differences between depletion and enhancement MOSFET? Feature: depletion MOSFET, enhancement MOSFET. Channel type: conducts without a gate voltage, needs gate voltage to conduct. Channel is naturally conductive and can be turned off. Channel is normally off and is turned on with gate voltage. Application: used in analog circuits, used in digital logic circuits. 6. C. What is load line and operating point? 1. Load line, a graphical representation of all possible operating points of a transistor in a given circuit. It intersects the transistor's characteristic curve to determine the operating point. 2. Operating point, Q point, the steady-state voltage and current at which a transistor operates. located at the intersection of the load line and the transistor characteristic curve. 6. D. State and explain the superposition theorem. Superposition theorem. In a linear circuit with multiple independent sources, the total response, voltage or current, is the sum of individual responses due to each source acting alone, with all other sources replaced by their internal impedances. Hash steps to apply superposition theorem. 1. Consider only one independent source at a time. 2. Replace all other sources, voltage sources, short circuit. Current sources, open circuit. 3. Calculate the individual response. 4. Sum up all individual responses to get the final result. Application, used in analyzing complex circuits with multiple sources. These are the best and most detailed explanations for your questions. Let me know if you need further elaboration. Present tense examples. 1. She reads books every day. 2. They play football in the evening. 3. He works in a bank. 4. The sun rises in the east. 5. I go to school regularly. 6. We love watching movies. Watch 5. A. What is an operational amplifier? What are the salient features of an op-amp? An operational amplifier, op-amp, is a high-gain electronic voltage amplifier with differential inputs and a single-ended output. It is widely used in signal processing, filtering, and mathematical operations like addition, subtraction, differentiation, and integration. Present tense examples. 1. She reads books every day. 2. They play football in the evening. 3. He works in a bank. 4. The sun rises in the east. 5. I go to school regularly. 6. We love watching movies. 7. She teaches English. 8. He sings beautifully. 9. Water boils at 100 degrees Celsius. 10. They always help the poor. 11. I am reading a novel. 12. She is cooking dinner now. 13. We are watching TV. 14. The children are playing outside. 15. He is studying for his exam. 16. They are traveling to London. 17. She is writing an email. 18. The baby is sleeping. 19. I am learning French. 20. It is raining heavily. 21. I have finished my homework. 22. She has bought a new car. 23. We have visited Paris. 24. He has just arrived. 25. They have already eaten lunch. 26. I went to the market yesterday. 27. She studied all night. 28. He played cricket last week. 29. They traveled to Japan. 30. We watched a movie. 31. She cooked dinner for us. 32. He read the newspaper. 33. I wrote a letter to my friend. 34. The dog barked loudly. 35. We enjoyed the party. 36. I was reading a book. 37. She was cooking when I arrived. 38. They were playing football. 39. He was studying for his test. 40. We were watching a movie. 41. The baby was sleeping. 42. I was working late. 43. She was listening to music. 44. They were traveling to India. 45. It was raining heavily. 46. I had finished my work before he arrived. 47. She had already cooked dinner. 48. We had visited the museum before it closed. 49. He had written the report. 50. They had left before the storm started. Future tense examples. 51. I will go to the market tomorrow. 52. She will study hard. 53. They will travel to Canada. 54. He will play football next week. 55. We will watch a movie tonight. 56. She will cook dinner for us. 57. He will read a book. 58. I will write an email. 59. They will enjoy the trip. 60. We will have fun at the party. 61. I will be reading a book at that time. 62. She will be cooking dinner. 63. They will be playing football. 64. He will be studying for his test. 65. We will be watching a movie. 66. The baby will be sleeping. 67. I will be working late. 68. She will be listening to music. 69. They will be traveling to France. 70. It will be raining tomorrow. 71. I will have finished my work by then. 72. She will have cooked dinner before we arrive. 73. We will have visited the Eiffel Tower. 74. He will have written the assignment. 75. They will have left before you come. Let me know if you need more examples. Here are 75 example sentences covering different tenses. Present tense. 1. I eat an apple every morning. 2. She plays the piano beautifully. 3. They go to school by bus. 4. The sun rises in the east. 5. He speaks English fluently. 6. She is reading a book now. They are playing football. 8. I am writing a letter. 9. 9. The baby is crying. 10. We are watching TV. 11. He has finished his homework. 12. She has visited Paris twice. 13. They have already left. 14. I have seen that movie before. 15. We have lived here for 5 years. 16. He has been working for 2 hours. 17. She has been studying all night. 18. They have been playing since morning. 19. I have been waiting for you. 20. It has been raining since morning. Past tense. 21. I ate an apple yesterday. 22. She played the piano last night. 23. They went to school by bus. 24. The sun set at 6 p.m. 25. He spoke English fluently. 26. She was reading a book. 27. They were playing football. 28. I was writing a letter. 29. The baby was crying. 30. We were watching TV. 31. He had finished his homework before I arrived. 32. She had visited Paris before. 33. They had already left before we reached. 34. I had seen that movie before. 35. We had lived there for 5 years before moving. 36. He had been working for 2 hours before the break. 37. She had been studying all night before the exam. 38. They had been playing since morning before it rained. 39. I had been waiting for you for an hour. 40. It had been raining for 2 hours before it stopped. Future tense. 41. I will eat an apple tomorrow. 42. She will play the piano in the evening. 43. They will go to school by bus. 44. The sun will rise at 6 a.m. 45. He will speak English fluently. 46. She will be reading a book. 47. They will be playing football. 48. I will be writing a letter. 49. The baby will be crying. 50. We will be watching TV. 51. He will have finished his homework by then. 52. She will have visited Paris by next year. 53. They will have already left before you arrive. 54. I will have seen that movie by tomorrow. 55. We will have lived here for 5 years by next June. 56. He will have been working for 2 hours by noon. 57. She will have been studying for 3 hours. 58. They will have been playing since morning. 59. I will have been waiting for you for an hour. 60. It will have been raining for 2 hours. 61. I usually wake up at 7 a.m. 62. She is cooking dinner now. 63. They were watching a movie when I arrived. 64. I will call you later. 65. He had already left before we came. 66. She has been learning French for a year. 67. We are going to visit London next month. 68. He does not like coffee. 69. She did not go to the party. 70. They will not come tomorrow. 71. Have you ever traveled to Japan? 72. Did you finish your homework? 73. Will you join us for dinner? 74. He has just finished his work. 75. By the time you arrive, we will have already started. Let me know if you need more.